and welcome back, and we're on to the Corbett Hire plus 5 a day, and we are on the 19th of January. Let's go with the first question. Okay, so what do we got? So we've got probability question. So the events A and B are mutually exclusive. That means they cannot happen at the same time, which means they cannot overlap because you cannot have the two things happening. So in other words, it must be the case that the two events are like this, which means the probability of A happening or B happening is going to be 0.9. So a good example of this, for example, might be choosing colours of socks from a drawer, classic sort of probability question. I can't choose, if I'm choosing one sock, I can't choose a black sock and a blue sock. I can either choose a black sock or a blue sock. But what's the probability for having a black sock or a blue sock? Well, you work out the probability of each and you add them together. So that's basically what I'm doing here. Good first question, nice and straightforward. Next question, write in the form of A root B. Now, it's telling you how to write it, which means I need to make sure I do that thing. In this case, I've got a denominator with a surd in, so I'm going to multiply top and bottom by the surd, and that's going to give me 24 root 6 divided by root 6 times root 6 is 6. 24 divided by 6 is 4, and so that's going to give me 4 root 6. That is in the right format. I'm happy with that. Good. Next question. Prove algebraically that the sum of the squares of any two odd numbers is always even. Now, it doesn't say consecutive, it says any two. So therefore, I'm going to let my odd numbers. Now, again, there's not a lot of space here. So I'm going to say let my odd numbers be, and I'll choose m and n. So 2m plus 1 squared and 2n plus 1. Actually, let's do the squared afterwards. Let's just write the numbers first. So 2n plus 1 and 2n plus 1. And then if I draw the arrow, it's clear what I'm doing then, isn't it? So 2n plus 1 squared and 2n plus 1 squared. Now, what does it want me to do? Prove algebraically the sum. So I need to add these together. So 2m plus 1 squared plus 2m plus n, 2n plus 1 squared. And I want to prove it's always even. So in other words, I need to be able to factorise the 2 out. So let's do the expanding. So that's going to be 4m squared plus 2 times 1 is 2, double it is 4. So 4m plus 1 plus 4n squared plus 4m plus n. Keep writing m instead of n. Let's write that again neatly. Obviously do a better job than mine doing it at the moment. 4m plus 1. And then, again, what am I trying to do here? I'm trying to show I can factorise out of 2. So let's make that really clear. So that's 4m squared plus 4m plus 4n squared plus 4n plus 2, which equals 2m squared plus 2m plus 2n squared plus 2n, I forgot the 1 at the end, plus 1, as 2 is a factor, even. Now, space is limited slightly what I'll say here, but for GCSE, a bit more flexibility. You don't have to be quite as rigorous in exactly what you say, but question answered. All right, I've got a feeling this last question is a nice long question. Work out now. I'm doing this, as you maybe I'll tell, on an iPad, so this won't be super accurate, but it's going to be close enough. Work out the rate at which the pulse is increasing at 4 minutes. Now, the rate of change is gradient, so I want the gradient at 4 minutes. I'm going to do my best job without a ruler on an iPad of drawing a line that represents the gradient. So as long a straight line as you can get. So that's going to be my straight line through 4. And then I need the triangle that represents that. So I'm going to use this point here. So I need them as far away as I can. So that's going to be, okay, well, let's look at my y values. So the y values go from 110, 120, go from 130 minus 60. Divided by the x values go from, what's the units, 0.2, it's pretty much in the middle, isn't it? So 5.5 minus, that's nice and easy, 1. So get my calculator out. Again, you do a much better job of this in an exam with a piece of paper and a ruler and the ability to actually see your line slightly better than I've done it. And I've got a gradient of 15.5. Now, I think anything that starts with a 1, so 10, 12, 15, so I think you're okay. I don't know the exact value here. I could probably work it out separately, but I don't know the exact value you're supposed to get. But something in that order would be correct. Now, because, well, actually not even because, it says here, doesn't it, include units. What are the units? Well, the units are beats per minute per minute. So therefore it's going to be beats per minute, or in other words, per minute squared. You could also do that. Work out the rate at which the pulse is decreasing at 7 minutes. Oh, we've got a very similar question then. So now I'm going to do the gradient at 7 minutes. So I did such a good job of the last one. Let's do another one. Again, these are actually not too bad because you can kind of see it's almost already a straight line, isn't it? So that's going to be my other line. And then I'm going to take this point here and this point here because it just means my y value is a bit more accurate. And so that's going to be, well, the y value is 130 minus 70. So it's 130 minus 70 divided by, remember this is actually a negative gradient, so we need to answer this question carefully. And I'm going from 3.6, 3.5 up to 12. So 12 minus 3.5. Now, my 130 and 70, by the way, is back to front how I would do it, but I know because I'm working out the rate at which it's decreasing. Okay, so it's 130 minus 70 divided by 12 minus 3.5, which is going to give me an answer of 7.05. So I'm going to call that 7.1 beats per minute. I'm going to call that beats per minute squared, just to write something different. Now, going back to this question, the question says work out the rate at which is decreasing. So I would actually just make it really sure I know what I'm doing. So 7.1 beats per minute decreasing. And it just kind of means I've confirmed I've understood the question, especially given I did this back to front. A nice little question to finish. And as ever, I really like this question. So we've got a good probability question to start, showing you understand terminology. Bit of surd, rationalise the denominator, some proof, and a nice little gradient question at the end. As ever, do like, subscribe. Any comments down below, I will get back to you, and I'll see you for the next one. Thanks all.